Good morning, all. My name is Gitanjali Mishra, research scholar at CIT University, Guntur, and it's my great pleasure to present my conference paper, which is titled as Two-Phase Ensemble Learning Based Extractive Summarization for Short Documents. So this is the abstract of our paper. So basically, the text summarization that is categorized into two types, that is extractive and abstractive. In extractive summarization, uh, we are just speaking of the important sentences from the document, which will be in the summary. But in case of abstractive summarization, so we are changing the sentences, uh, but we are not changing the meaning and the semantic of the original document, which will be the output as a summary. So, but in case of your extractive summarization, it will not handle the confliction data correctly. So, to handle that conflictions in the summary, we are using different deep learning models are available. So, by using the deep learning models, so that contradictory data can be corrected. So in our paper, we have introduced the multi-phase ensemble learning technique with the help of stacking method. So to get the output, finally, we are using or we are applying the logistic regression so to get the output. Uh, then after getting the output, that output will be compared with the existing models. So mainly here we are using the RUS as the metric evaluation to compare our proposed model with the existing state of art. So these are the some of the literature surveys we have done. So in the article 4, so the methodology used as CNN, post-trigger, NLP parsers. So by using that, the MDUT from which is removed from the output by using the parser, and the sentences are combined using the SVO rules. So by using this also some of issues are there, like here we use the uh, old RUS2 document consisting of only F score from DUC 2007. So for the evaluation of the summary, RUS is the matrices which has been used in this article. So in the fifth article, the LSTM and the combination of CNN that will be used for semantic parsing. This model gives the advantage. Model takes phases rather than words, input and output. The sequence to sequence context will be ready, and here we can tune or change the parameters. Here the issue was that MOSP can help us to extract more phases. This method will also extract some wrong and repeated words or the phrases which cannot be distinguished. So here we have here average number of occurrences of the word in each text before and after pre-processing. That is the matrices which is used in this fifth article. Then in the sixth article, the neural based semantic compression is used as a methodology, and by using this methodology, we are getting the benefit like compressive approach substantially outperforms the comparison augmented let some model. But thing is that here also you are getting some of the demerits, like it is grammatically incorrect, and to here the Tunker's rating grammatically were very noisy and did not consistently rate truth article sentences above the noise variant. And for the evaluation, the ROS is used for the accuracy. In the seventh article, the methodology is used as a neural network. So by using this neural network, so the approaches that is used as simple feed-forward neural network. So it is implementationally and computationally very light, and obtains it gives more performance accuracy as compared to the existing models. The demerit is the size of the input layer is fixed. We cannot alter the size of that neural network. Then next article is our eighth. There we use the evaluation technique combines export and crowdsource human annotations so with results from neural summarization models. By using this methodology, we got the advantage like overcomes it will overcome the shortcomings of the existing summarization techniques. These are the some of the literature survey we have done using different articles. So in our proposed model, we have used two-phase ensemble learning. In the first phase, we have used bidirectional LSTM with the CNN. The two are combined in the first uh, phase. So this is the so in first phase, we ensemble the bidirectional LSTM with the CNN. In the second ensemble, we have these output of the primary ensemble that will be inputted to the secondary phase ensemble. There we have used three models: random forest, SVM, and KNN. So after that, the logistic regression is applied to get the final summary. So here we use the dataset as a BBC News dataset. So earlier we are using the LSTM. So why we are using the LSTM? LSTM having the means it can memorize the sequences, and it has some demerits about that. We are using the bidirectional LSTM. So mainly it stores the long sequences. For that purpose, we are using the bidirectional LSTM, and it deals with the gradient vanishing problem, and it gives better prediction because here the comparison or input is done in the past and future direction. So in the both direction we are getting the input, so it gives the better accuracy and the better result as compared to LSTM. And here in our proposed model, many bidirectional LSTMs are used with the concatenation, and finally we are applying the softmax function to get the output. Next, we are using in the first ensemble the CNN, convolutional neural network. So here we are using the inception race V2 architecture. So it is most popular because it has a 3x3 convolution with the base normalized. So here we are using the base normalization with the help of factorization. So which increase the performance, and with the help of multiple convolutions base normalization, the output will be more accurate as compared to the single CNN. So in the second phase, we are using the output of this primary ensemble that will be given to the secondary ensemble, which consists of KNN. So mainly this KNN is used for regression and classification purpose. So it will find the distance between the user input and the specified set of examples, that is K. So mainly to find out the distance, we are using the Euclidean distance. This is the formula, that the square root of x2 minus x1 so whole square plus y2 minus y1 whole square. Next is we have used that support vector machine. So this SVM is also this algorithm is used mainly for the labeled data learning. So here it will use the hyperplane to group the data. Next is your random forest. So this random forest algorithm is used for the level data. So what will happen? Your multiple decisions trees are created. So out of that, randomly the decision trees will be collected, and it will create the forest, which consists of set of decision trees which must be dense. So which will give more accurate result. So the decision after selecting the decision trees randomly, the best solution to each tree will be given the output, and from that which tree is giving the best prediction on each tree, that will be selected as the final output. So how do we select the output? By using the voting system. So this is our proposed architecture. Already I have explained. So first the BBC data set, the data news that will be inputted to the bidirectional LSTM and to the CNN. This is the primary level of ensemble. So individually these inputs are given to these two model that will give the output to the secondary phase of ensemble. So here the input will be given to both bidirectional LSTM and CNN, and they will produce the individual output. Finally, we are aggregating these outputs of bidirectional LSTM and CNN by calculating the accuracy of them. And these output will be given to the secondary level of ensemble. So in primary ensemble, the text will be inputted to both the models, but that is bidirectional LSTM and CNN. Both the model will produce their individual result. Then the voting method is applied to get the desired output by calculating the accuracy of each model. Now that will be selected as the final output of the primary ensemble and given to the secondary level ensemble. In the secondary level, we have used three modules to evaluate the result of primary ensemble. The three models are your KNN, random forest, and SVM. So here we are checking the accuracy of these three models in the context of the summary. Then after we are applying the logistic regression to get the final summary. Mainly this logistic regression is used to calculate the probability of each model and then to select the model having the highest accuracy as the output. Finally, we are getting the classified output. So in our proposed model, we are using the dataset as BBC News dataset. From here, we use two articles from each of these new news categories like business, entertainment, politics, sports, and technical. So on the basis of the scores obtained from each and every article, we analyzed our proposed model. So here mainly we are using the evaluation matrices as the ROS, that is recall oriented understanding for listing evaluation. So here we are applying the RUS1, RUS2, and RUS-L. And in this RUS method, mainly we are calculating the F score, R score, and P score. So these RUS will compare the automated text summary which is generated by the machine with the human generated text summary. So the proposed, this is the experiment results that we have seen. The proposed model used to be utilized for BBC information statistics set. So we calculated the RUS score of each and every model to know the accuracy at the primary level, which is presented in the table 2. This is the primary level ensembles scores which we have seen. We calculated the RUS1, RUS2, and RUS-N with the help of fall, recall, and precision. Similarly, for the secondary level also, we have calculated the score by using the ROS, then applied the aggregation using the voting to get the result. This is the evaluation matrix of the primary ensemble. So here we have used 4 categories, that is business, politics, entertainment, sports, technical. So here we calculated the average of these ROS1, ROS2, and ROS-N. So this is the score, and this is the score. This is the accuracy of our bidirectional LSTM and CNN, which is used in the primary ensemble. And this is the accuracy or the matrices which we got at the secondary ensemble for random forest, SVM, and KNN. The table 2 shows the experimental result result of the RUS course. So, a 15 device task tested on the proposed summarization architecture. So, here we have obtained the fall, recall, and precision parameters of RUS1, RUS2, and RUS-L scores. So, here one observation we have seen that the third article, that is the politics category, has obtained the lowest RUS scores, while the second article in the technical category has achieved the highest scores. Similarly, the table 3 and 4, this is the table 3 and 4. So here we have seen the primary and secondary ensemble results that we have presented here. So then after getting these values using this RUG matrix, so after that we have done the comparison of our proposed model with the existing model. So in this paper we have compared our generated architecture with the other existing ones. So we have compared the average fall, average precision, average recall values of RUS1 score of our generated model on the three other existing models that is available in the table 5. So we have seen that the model we have opted for the comparative study are Ahuja, an online text summarizer, and mRNN model. So on the comparison of the average ROS1 score of the models, we have seen following results. We have seen that our proposed model gives the highest score than the existing ones. So this is the comparison we have done. So mainly we have done comparisons with the three existing state of art models, that is MLP. So in the first model, the model we have used the MLP based. In the second model we have used the Ahuja, and the third, that is a multimodal RNN based. Both these all are for only the extractive summarization. So in the first model, CNN Daily Mail dataset is used. In the second model, DOC 2002 dataset is used, and in the third we use that CNN Daily Mail. And these are the average fall, recall, and precision scores for this existing three models. So here we have seen our proposed model that is also for extractive summarization. So here we used the BBC News dataset, and the average fall score is 0.59, and average recall is 0.556, and average precision is 0.478, so which is more than of the existing three models. So this is the graph for which is the ROC score. So here we have seen that for the BBC data news data set we have seen. So this is the primary level score, and this is the secondary level score. So this gives the highest accuracy as compared to the existing ones. So this is the comparison of our proposed model with the three existing one. This shows the our proposed model having the highest fall, recall and precision as compared to the existing three models. And then goes to the conclusion and the future scope. So here the automatic text summarization is difficult task which consists of multiple subtasks, each subtask having its own capacity and own quality of the summary. So in this article we have proposed models for the extractive based summarization for the text only. The proposed model we are using the deep neural network based on the two level of ensemble learning. In the first level we train the CNN and bidirectional LSTM model. Then its output is given or inputted to the secondary level of ensemble. In the secondary level, we have trained KNN, SVM, and random forest model. This level gives the reclassified output. Then finally, to get the summary, we are using the logistic regression to get the final output. The proposed model's result is the promising one, as its accuracy is more as compared to the other models. In the future, we are planning to apply two-phase ensemble learning for the abstractive summarization. The work can be elongated in the future by using other matrices, and we can also use the other deep learning models to get the better accuracy. So this is our future planning. So these are the references which I have done for my proposed model. Thank you.